right, here we go. Let's take a look at a new chapter here. We are going to graph some trig functions. This is pretty awesome. When you're graphing sine and cosine these trig functions, it's like doing circles. We are graphing circles repeatedly. It's going to be pretty awesome. We're going to look at amplitude in midline. It's going to make sense at the end. Let's get going on this. This is pretty awesome. Check out this problem right here. We actually ended last chapter with this. So the very last problem from 9.3 on the packet was, hey, let's fill out these values for theta here and graph them on and see what happens. So you probably have this in your notes if you finish up, or I'm sorry, in your application if you did last time. If not, no worries. We're going to do it right now. Check it out. So this is, remember what's happening if I'm putting different values in my calculator. So if I put in the decimal value, the approximate value. So if I want to know, hey, what is the sine of 60? You put in the sine of 60. And that's where I'm getting this 0.86. I did a little rounding here. I know it goes on more than that. So all we're going to do is plot these points. So let's get this bad boy rolling. What I would recommend is don't write these down just yet. What I would do, oops, excuse me. I would go ahead and watch this through and then at the end copy down the final graph. So just watch what's going on here. If you don't like f of x or f of theta, it's the same thing as y equals sine of x. Some people prefer just x and y, old school. No worries, there's a function notation. I'm going to do both, so make sure you can handle both. But for the first time, you can think of it as x and y if you want. So let's plot this point. 0 degrees makes 0. That's the easiest point, the origin, 0, 0. And I can see it's this point right here. Remember, this point is over 1 up 0. And we're talking about sine. It's the sine value. It's that 0 value there. So pretty cool here. So we've got 1 point done. Check it out. What happens as we go around the unit circle? So here's 30. 30 is at a half. And check it out, there's a half. So 30 makes a half. Boom. 45 is 0.7. And you can see we're talking about the y value here. We're talking about if this is the triangle from the unit circle, it's all about this unit circle. Remember, this is the angle. We're talking about sine is opposite. So in this case, it's 0.7 up. And the hypotenuse is a unit circle of 1. So we're talking about this height, which makes sense. It's this height over here. Isn't that pretty cool? So it totally is the unit circle. Boom, 60 degrees is 0.86. And then what happens when I hit that 90 degrees? I'm all the way up at 1. So I'm just going around the unit circle. All I've done so far is I've gone around and taken the y values around the unit circle. Pretty cool, huh? Let's keep this bad boy going. So now I hit the next quadrant. I hit quadrant 2, so I changed it to blue. Pretty fancy. And if you notice, it's the same values, isn't it? These are the same decimal values. They're all lined up here. 150 is 30. Same y value. Super cool. Back down to 180 at 0. Sweet. Let's keep this train going. Now I'm hitting quadrant 3, so I'm actually hitting negative. But again, it's the same numbers. It's the same y value, but now it's just negative. Sine is actually negative in the third quadrant. And as I go around 225, 240, 270, now I've done the whole third quadrant. And then let's wrap it up with a fourth quadrant. Changing colors again. Here we go. Green. Ooh, I love it. I love it. I can do this all day. And it's a 330, and then finishing the unit circle at 360. So that was one whole trip around the unit circle. We graphed all the y values around. Now, we could do this forever. I could do 2 circles, 3 circles, 4 circles, and just go and go and go, and you get this shape. What shape do you get? You get this nice curvy sine curve. Ooh, that's not bad. I'm hitting all those dots pretty well. So it's not pointy or sharp. It's curved. It curves up, comes down, curves back up. And again, this goes on forever and ever, ever. That was one trip around, but I could go around and around and around and around and around and keep on going around the unit circle. This is creating like sound waves and things like that. So we're going to use this for a lot of cool word problems coming up. Excellent. So that is the sine graph. So what do you need to know? Check it out. This is a better color-coded one. What I've gotten here is our main points here. So 0, 0, see how it's in black? These are the quadrantals, I think is what they're called. It's where it hits the axis. So it's not in a quadrant, it's on the axis. So these are our main points right here. We start on 0, we end on 360. These are really the 5 points I want to see you graph through this chapter. So we're just going to graph these main 5 points. So basically I'm going to graph coming up to this, boom, coming down to this black one again, coming down to the black one, and the black one. There's tons of infinite points in between here I could graph if I really want to, but the general idea is if I can hit these 5 black ones, boom, I'm good to go. These 5 main points, that gets me one trip around, and I'm good to go. So I think I put a fancy graph. There it is, perfectly in there. If you want to see it perfect. That is one trip around the unit circle. Fantastic. So let's start graphing these bad boys. So really, we're going to fill in full charts. We're not just going to stop with one circle. So the idea for sine is I know it starts at 0. And I know when I'm done, I end at 0. And I know in the middle, I'm at 0. So we're going to kind of do so many, you're just going to memorize them. But if you want to just kind of reference back to your unit circle, ooh, that is a rough one right there. Sorry. I hope yours looks better. But it can be rough. It doesn't matter. As long as you know your points. This is 1, 0. This is 0, 1. This is -1, 0. And this is 0, -1. So as long, my coordinates shouldn't be rough. I got to draw a line somewhere here. There we go. So if you think about the sine, the y values, I start at 0, I go to 1, I go to 0, I go to -1. So I start at 0, I go to 1. So in between these, at 90, I'm going to be up here at 1, back down to 0, back down to -1. It's always going to do this. Now we're going to change it, tweak it a little bit, but this is the general form. Those are the 5 points I want to see you hit: 0, 90, 180, 270, 360. I just went around and took the y values and did that. Could you do it in the negative direction? Sure, just go backwards. You go from 0 to -1 to 0 to 1. So it's the same thing. I always kind of, so it goes to -1, back up to 0, back up to 1. There we go. And so the highest or lowest it's going to get is 1 because it's a unit circle. That's as big as our unit circle gets. Boom. That is really it. And it goes forever and ever and ever both directions. So we're going to fill up the graph paper. Anytime you can, I want you to fill up the entire graph paper. Awesome. Is it going to freak you out if we do that same thing for radians? I hope not. It's the same thing. It's the same thing, but instead of 90, what is this? This is pi over 2. This is pi. This is 3 pi over 2. And this is back to 2 pi or 0 pi. Awesome. So really, if I do it in radians, it's the same thing. I start at 0 pi. I'm going to go up to pi over 2 is at 1. Pi is back down to 0. 3 pi over 2 is 1. 2 pi is back there. It's the same exact thing, but we just changed it to radians is all we did. And again, we can do it in the negative direction. We're hitting those 5 points, and we are good to go. Negative direction. So we're going to do it both radians and degrees. Ooh, that was a little rough there. Awesome. Is that pretty cool? So it doesn't matter if it's in radians or degrees. When we start doing word problems and everything, we're really going to focus on radians. This is what we're going to be switching to, so the more comfortable we are with that, the better. So that is sine. What about cosine? So this time I went ahead and put the exact values up. Remember, those were all approximate decimals, but we're going to do it with the exact values if you want. This time we're doing cosine. Remember, what is cosine? Cosine is actually the x value. So it's x comma y or cosine comma sine. So now I'm going to be looking at, those are too close in color. Let's mix it up. I'm looking at these x values when I graph it. And these are the exact values, but I'm going to kind of convert them to approximate decimals as we go. Basically, what's the difference here? It's all the same numbers. These are all the same things. But what's the difference at 0? Do I start at 0? No. What is cosine at 0? It's actually at 1. Holy cow. I'm actually starting at 1. Let's just go ahead and hit the quadrantals. I love that word. Where am I going to be at 90 degrees? I'm going to be at 0. Where am I going to be at 180? I'm going to be at -1. So at 180, I'm down here at -1. And when I hit 270, I'm going to be at 0. And then I'm back to 1 at 360. So this is actually the cosine curve. Now I can hit all these points in between, the 0.866, the 0.7, the 0.5. But what's going to happen with this curve? It's going to curve down to the 90. It's going to curve to the 180, curve back up to the 270, curve like that. So it's still the same thing. Sine and cosine are still the same. If I continue this forever and ever and ever, you get that same wavelength going on there. The same thing going on. It's just kind of like almost shifted over because it starts at 1. We're just starting it at the same place. So sine and cosine are really the same graph. They just start at different places. So for cosine, that is one trip around the unit circle right there. That's going to be important coming up. One trip around. Awesome. So what do I need you to know? I would jot this down, have this. This is huge. If I have a graph, sine looks like this. Sine starts right on the 0. It ends right on the 0. In the middle, it's on the 0. And in between, it's going to be up 1 and down 1. So that is the sine curve with the 5 points. Jot that down. Have that. That is huge. We're going to do so many of these this chapter. You're just going to know them inside and out. So don't freak out. It's going to take a little time. What is cosine? No worries. Same thing, but it starts above the graph and it ends above the graph In the middle, it's below the graph. And then in the middle is when it hits the zeros. So get these 5 points down, Pat. Whoosh, throw that bad boy in there. That's cosine. So those are the 5 points I'm looking for in all of these. Plus, we're going to do extra to fill in the graph. That is sine. That is cosine. I love it. Let's start doing some problems now. Let's start really graphing these things. So this is the standard form. Y equals a sine x plus b. And we're going to talk about the coefficient here, this a and this constant out here, b. What do these mean? What do these do to your graph? So I was just doing sine x. So we're going to talk about the a term first. A term, actually, conveniently enough, stands for amplitude, which is the distance from the center. How far is it? So it's a distance. So if I look at this, f of x equals 3 sine x, I put this 3 in front. So it's all this is going to do is stretch it 3 times bigger. It's like old school when we were stretching graphs and whatnot. So if I think about my normal sine curve, let's just do a normal one. My normal one starts at 0, ends on 0, in the middle it's in 0, and then it's up 1, down 1. This would be normal sine right here. But I don't want normal sine. I want the sine of 3 sine x. So it's going to be 3 times bigger. So instead of going to 1, it's going to go to 3. It's still going to hit your zeros. But instead of hitting 1, it hits 3. Instead of hitting -1, it hits -3. And see what I've done here? I've stretched it out. So that is actually the graph, the red one there. Isn't that cool? Same thing on the other side. I know it's going to hit 0 and 0 again. But instead of hitting -1, it hits -3. Instead of hitting -270, it hits positive. Instead of hitting +1, it hits +3. I can barely talk. Holy cow. It's the red graph. Is that awesome? So we're just going to stretch it out. So if I look at this and say, hey, what's the amplitude? You can say, oh, my amplitude is 5. So what is the cosine? So you got to think, okay, where does cosine start? Cosine starts above at the axis at 1, but it's not going to start at 1. Where's it going to start? It's going to start at 1, 2, 3, 4, 5. So now it's stretched out. I know it ends at 2 pi or 360. It ends above the line. In the middle, it's below the line, but not below 1. It's below 1, 2, 3, 4, 5. And then in the middle of the middle is where it's hitting the 0. So all I've done is stretch this bad boy out. Wow. There it is right there. Holy cow. Can I keep it going? Sure. I know it's here. It's going to end above the line at -260. In the middle, it's below the line. And it's going to be symmetric. It's going to look the same. If it doesn't look the same, something's off. It's got to be a nice flowing wave forever and ever and ever. There it is, man. 5 cosine. So instead of just doing a normal cosine graph at 1, I just raised it up 5. Uh-oh, we got trouble here. Negatives. This is a beatdown. So I kind of left this off. Can we go back here? These are positive graphs right here. This is a positive cosine. Positive sine. This is a positive cosine. What about negatives? Well, don't freak out. I'm just going to do it below here. I hope you have room on your paper. I'm going to do the negatives. So all the negatives are going to do is flip it. So instead of, I still start here at 0. I end at 360. In the middle, I'm here. But what's the difference? Instead of going up 1, I'm going to go down 1. And then I'm going to come back up like this. So it flips the graph. So we got to know the negative flips it. I just kind of jot these down on my paper to look at them, reference them. This is a positive sign. This is a negative sign. How about negative cosine? Same thing. Instead of starting above the graph at 1, it starts below the graph. It ends below the graph. The middle is above the graph. And then the middle of the middle is where it's hitting here. Those are my 5 points that are hitting the axis on the unit circle. Or think of this as a flipped cosine curve. It just flips it upside down. So you got to know these 4 graphs. Jot them down. Have them on your paper. Refer to them. This is what we're doing. Then it's just a matter of stretching them up or down is all it's doing. Awesome. I love it. So this is pretty tricky right here. I put a pretty tough one to get us going. -2 cosine. So it's the amplitude is 2. And you're maybe thinking, well, is it -2? It's not. It's a distance. Remember, it got deleted here, but remember, it's a distance. Distance is positive. So we're going to say, I know it's negative there, but we're going to say the amplitude is a +2. But because it's negative, instead of starting up here at 2, I am actually going to start at -2. So I'm going to put a dot here. I like to say, where will I finish? I'm going to finish below the line in this case. In the middle, I'm going to be above the line, not 1, but 2 because of the amplitude. And in the middle of the middles is where I hit these points. So this is going to be my -2 cosine. So this is our goal, graphing things by hand. Can we make these graphs? Boom, that is amplitude. I'm throwing a lot at you today. I love it. It's going to get easier as we go, I think. I think the next two sections will be much easier. I'm just kind of throwing everything out there. Let you practice, deal with it. That sounds terrible. Let you practice it, get better at it, hammer it out, and then it'll get easier once you get through this first section. All right, so we have another part. That was just the amplitude. The other part we're going to look at today is this constant out here. What does the plus b do? Well, this is the actual center line, or what is this? This is the vertical shift. Remember back from, I can't remember what chapter, chapter 5? We can raise things up or down. So I'm going to raise things up or down. So if I look at this and I say, hey, where's the midline? Or sometimes I say, where's the vertical shift? The vertical shift is what? -3. It's down 3. And what does that midline mean? It means my line is at -3. So basically, I draw a little dotted line here. This is now where my trig function is. It's been shifted down 3. So if that 3 wasn't there, let's just pretend it wasn't there. I'm just graphing sine of x. So without the -3, it starts there, ends there, middle's there, middle of the middle's above, middle of the middle's below. There's my sine curve. Yay! That's awesome. Great sine curve. So what did I do? I shifted it down 3. I'm going to take the sine curve, and I'm going to shift it down 3. It did not take the points. Oh, there we go. Now I can take the points. Everything gets shifted. Not the graph. What? The graph doesn't get shifted down 3. Okay, I got the point now this time. All the points get shifted down 3. So I slid that graph down 3 is all I did. So that is what the midline is. And then I can continue it in the other direction. Just keep it symmetric on both sides. Boom. Like so. And there it is. There is my sine of -3. If I ask you specifically what is the midline, it's this dotted line, and it is y equals -3. It's this, remember, it's a horizontal line, so it's like a y equals. That is the midline. Awesome. What is the midline of this one then? Well, it's a vertical shift up 2, so I would say it's y equals 2, or no, it's a vertical shift up 2. So I always draw the midline. So at 2, I think this will really, really help. Draw that midline in. Y equals 2, it's shifted up 2. There it is. Why is it so helpful? Because now I can deal with the fact that it's cosine and not sine. Remember, sine starts on it. Cosine doesn't. Cosine starts above 1. It's going to end above the line 1. In the middle, it's going to be below 1. In the middles of the middles, it's going to be touching. Now I've graphed my cosine curve right there. Boom. Killing it. I love it. Let's just keep it symmetric. Keep it going on the other side. And again, you'll do so many of these, they'll just start flowing. So if it's weird now, it's okay. Do some practice. If that's not enough, do the corrective. If that's not enough, do the corrective. Another corrective. Just keep on going. All right, here we go. These are the two hardest ones. I'm sorry, this is the hardest one I could think of for right now. It's got a little bit of everything. So I've got a B term. I've got a phase shift, or vertical shift, I'm sorry. And then I've got an amplitude, and I've got a negative. Holy cow, bring in the pain. I love it. So let's talk midline. Where in the world is the midline? Well, it's a vertical shift up 3, so it's y equals 3. That is my midline. Is there an amplitude? Yes, it's 2. Remember, it's always positive. So I'm stretching that graph 2 out. So start with the midline. It is up 3, so put that dotted line in there. Can't recommend that enough. Draw that dotted line in there. That is the midline. Now it's a sine curve, so I know it starts on the midline, it ends on the midline, and in the middle of the middle, it's a midline. And notice, I know these are either going to be in radians or degrees. Doesn't matter to me because it's hitting the same 90, 180, 270. It's the same points. Awesome. So now I got to think about normal sine would be up here stretched to 2, but because it's negative, it's below the line stretched to 2. So it's down to 2, comes back up. In the middles of the middles, it's back up to 2. So remember, sine, I have to start going down, back up, and there it is like that. Keep this fun going. I have to complete it. I can't leave the graph hanging. It's the same points on the other side to keep that a nice, even flow wave. Boom, there it is. If that makes sense, you're a boss. If not, once you do enough practice, I think you'll get there. No worries. This is a good one. 2 more problems, and we are done and done. So what I want you to be able to do is take an equation and recognize it. Hey, what is the amplitude? The amplitude in this case would be a fraction. Don't freak out. It can be 1/3. You can go up 1/3, not always 2 or 3 or 4. And what is sometimes we call it the vertical shift. So you may see VS for vertical shift, or what is the midline? These are the same thing. What's the vertical shift or the midline? And in this case, what is it? It's y equals -12. Or what does that mean? Is a vertical shift? That just means down 12. So vertical shift down 12, the actual midline is this y equals -12. Awesome. There it is right there, down 12. What if I give you a graph? Can you still find your amplitude in midline? Let's just do amplitude in midline this time. I like to do my midline first. I like to get in there and say, okay, where's the middle? So I give you the graph. You have to come in here and draw the midline. It's right in the middle. It's the sine curve or cosine curve goes up and down above it the same. It's got to go above and below exactly the same. So there's the midline at what? 3? So y equals 3 is my midline. Now you can find the amplitude. How far above is it going? There's how far above it is. How far below is it going? And it's always going to be the same above and below. Just be careful with your scale. So I'm at 3. This is 2. So what is that? That's actually a half. So I only went up a half or 0.5 above and below it. It's always going to be the same, sometimes 3 or 4. With that information, could you write the equation? This is kind of a little bonus problem here. Could you write the equation? Sure, it starts here at 0. It ends here, so is this sine or cosine? It's sine, but did it go up? It's actually negative sine. It actually went down. So if I had to write this equation, I could say it's y equals negative because it's going down. Amplitude's 1/2. The sine of, let me rewrite that so it doesn't look wonky. I lost it all. Sorry about that. Negative 1/2 sine of x. And then what did I do? I shifted it up 3 plus 3. So at the end, after you've graphed a bunch of these, I may just give you some already graphed and say, hey, can you break this down and write the entire equation? That is boss level right there if you can do that. Holy cow. Try some of these, work them, grade them, see how you're doing. I think with practice, you'll nail it. I know it's a lot, but it'll get better. This chapter gets better as we go. It's like with age. It ages well. All right, good luck on the mesh check.